The second skill in our fourth learning unit here is on the first of three reactions that we're going to learn about that are aqueous chemistry. So first, we're going to talk about precipitation reactions. Then next, we'll talk about acid-base reactions. And then lastly, we're going to talk about redox reactions. All right, so precipitation reactions. When we learned how to write a molecular, total ionic, and net ionic equation, we learned how to do so actually with a precipitation reaction. So this was actually the reaction that we had. So I'm just going to take a minute and sort of summarize here what we had with that specific example. So in this case, we had a solution of silver nitrate that was mixed with a solution of sodium chromate. And when they mixed together, we got a silver chromate precipitate, which we indicate with a solid there. And then there was sodium nitrate that was left over that was aqueous. So these are all aqueous here. So when we have something that's aqueous, what it means is that we really have those ions in solution. So I'm going to write down what those ions are. I'm not going to worry about the number of ions that we have at this point. So these are the ions that we have in solution. And just refreshing our memory from our last lesson there, our last skill, things that appear on both sides of a chemical reaction are going to be spectators. But we only know that right now because we know what the product is. What we're going to see in today's lesson is when we have two aqueous solutions that we mix together, what we really need to ask is what are the two new possible pairing partners that we could have. So remembering that cations always pair with anions, we're never going to have two anions interact with one another. But what we need to ask is, can we have, rather than silver and nitrate interacting with one another, and we know that that doesn't form a precipitate, can silver find a new anion? And can sodium find a new anion? And what happens when those new pairings interact? Well, with one of those pairings, we're going to form a precipitate, and then nothing happens with the other pairing. So those other pairings generate those spectator ions. And spectator ions are the same on the left and the right side of an equation. And so when we write our net ionic equation, that's only going to have those species that participate in chemistry. So the net ionic equation has these three pieces. So highlighting what we're going to have here in red is going to be our net ionic equation. So at the end of the day, what I want you to remember for evaluating a precipitation reaction, we're going to have two aqueous solutions that we mix together. Because they're aqueous, each of them has those ions in solution. When we mix them together, there's the possibility for new pairings to form. Remember, those new pairings have to be a cation with an anion. We're never going to have two cations interact, and we're not going to have two anions interact. So when we're predicting precipitation reactions, those are essentially those same rules. So what we just did in the last slide, we're going to see here in words here. We need to note all the ions that we have in solution. We're going to consider all possible cation-anion combinations, noting here that we do not have cation-cation or anion-anion interactions. It's only a positive and negative that are interacting. For right now, you are going to have this solubilities rules chart provided for you. So what we're calling table 4.1, finally a chart you don't need to memorize or know something specific about. This will be provided for you. You just need to know how to use it. Basically, this chart is highlighting things that are always soluble or always insoluble, and sometimes there's going to be exceptions here. So one of the things that you'll start recognizing is patterns, trends, themes for certain things that are soluble. For example, all sodium salts are soluble, all potassium salts are soluble, all nitrate salts are soluble. So that's going to allow us to know that when we have those ions paired with something else, we're not going to be forming a precipitate. Any other possibilities, either it's something that we don't see that's here in terms of our always soluble or something listed with our always insoluble, If it's not listed here, you probably can presume that it's something that's forming an insoluble precipitate. So these are what we call solubility rules. It will be provided for you, but you could use this then when you figure out those new possible pairing combinations to determine if a precipitate forms. So let's just do this with one example here, and we're going to review and refresh our memory with the three kinds of equations that we had before. So what we have here is we're going to have two solutions that we're mixing together. We're going to have a sodium iodide solution that we're mixing with a lead nitrate solution. And just like we highlighted and talked about in the last slide, all sodium salts are soluble and all nitrate salts are soluble. So what we're actually going to have here is we're going to have two solutions that generate exclusively ions in solution. So let's say that the sodium iodide maybe is what's present there in our beaker. And let's say that our lead nitrate was in our graduated cylinder, and then the lead nitrate's what's in our beaker there. So let's think about what happens then. And this is writing our molecular equation. We're going to ask the question, what do we form on the other side? So what we might need to figure out first is, well, what do we have in solution? So this is this idea of breaking these down and asking, who do we have and what are the new possible pairings? So we've got sodium cations, iodide anions, lead cations, and then nitrate anions. So we know that nothing happens with sodium and iodide or lead and nitrate because those are aqueous solutions. But what we need to ask is, what about these new pairings? What about this sodium and the nitrate? What about the lead and the iodide? And so what we can do is come over here and come back to our chart and we can revisit it. All common compounds of group 1A, so lithium, sodium, potassium, are soluble. So this new possible combination of, and we can go ahead and write this here in our molecular equation, NaNO3 is going to be soluble. So we'll write that as aqueous. Now we need to consider this lead and this iodide here. So when we look here, we can look, all common chlorides, bromides, and iodides are soluble except, and there's our exception. So when we have an iodide that's with a lead cation, that's going to be insoluble. So that confirms for us that this yellow precipitate that we see here is lead iodide. Now again, we'd have to go through here if we want to have this be a balanced molecular equation. We have to go through and balance it. So there's going to be a 2 that's there and a 2 that's there. So this is our molecular equation. Now remember, if we're writing our total ionic equation, this is the one that's a little bit painful to write, but let's go ahead and just for practice, we'll write it out. We're going to have 2 sodium cations that are aqueous, 2 iodide anions that are aqueous, lead cations that are aqueous, plus 2 nitrate anions that are aqueous. And that's just the left side of the equation. Go ahead and then take it over to the right side of the equation. We're going to have 2 sodium cations that are aqueous, 2 nitrate anions that are aqueous, and then lead iodide as a precipitate. So that is our our total ionic equation. I'm rarely going to ask you to write a total ionic equation. I want you to be able to see it in your brain. I want you to be able to see who's floating around in solution. But taking the time to actually write it out is quite cumbersome. So it's not a skill that I'm going to ask you to do kind of regularly here. But going through and just again highlighting the species that we find on both sides of the chemical equation, we see our sodium and our nitrate. Right? That's highlighting again that they are going to be aqueous over on the right side of the equation. These are our spectator ions. So we're drawing and highlighting our spectator ions there. Spectator ions are eliminated when we write our net ionic equation. So the net ionic equation is going to be the important part of what we see here. And that's going to be lead, 2 plus cations plus iodide anions generates lead iodide as a precipitate. So the two skills kind of from our last video that are important to kind of take with you and be able to do is writing the molecular equation, which we've been practicing for a few weeks now with other kinds of chemistries, and then seeing what the net ionic equation is. Those are the two that are really important sort of carry forward skills. All right, so that is precipitation reactions.